Now, some of you guys kind of zone out in my class, so you gotta be careful. Don't zone out, because if you zone out, you're gonna be like 10 minutes pass by, you have no idea what Mr. E is saying. Make sure that you don't zone out. I think people who like to zone out, as Samuel like to zone out. He just kind of stare at a screen and like not do anything. But I mean, I don't blame you though. If I listen to myself, I would have zoned out too. Um, so, but just try not to. At least you can learn something for it. At least try to say, it's okay, I maybe don't zone out for a minute. Polynomial. What's qualified for polynomial? Polynomial is like if you have ax to the n plus bx to the n minus 1 plus cx to the n minus 2 all the way to, I don't know, some type of k, like plus a constant, it's plus k. So a good categorize a polynomial. So for example, like even 5, a constant 5 is actually a monomial. But you can say that's, this is also a polynomial. Or x plus 1, that is still polynomial, but we could actually call it binomial rather than polynomial. Anything more than 3 terms called trinomial. Anything greater than 3 terms is called polynomial. But you can pretty much call everything is polynomial, as long as it doesn't have square root or 1 over x, something like that. So imagine that f of x, so f of x have this equal to the axn plus bx to the n minus 1 dot 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 dot. This is the things I'm gonna pay attention on a polynomial. This is called leading coefficients, or leading term. With a leading term, there is a possibility for the n and a. Now, here's the thing. This n here is going to tell you how many solutions they are. They can be real or complex. I'm going to say that again. They can be real or complex. So this n is going to tell you how many roots does a function have. Roots or zeros, these are different names. Roots or zeros. Okay, it doesn't have x-intercept because sometimes it doesn't have x-intercept, even though it has roots. Okay, because there's something called fundamental theorem of algebra. Now, how many of you guys hear of a term called fundamental theorem of algebra in the past? Probably not, because nobody ever mentioned it before. So fundamental theorem of algebra is by a person. He's a very smart. He's 8 years old. He's already super smart. His name is called Frederick Gauss. Okay, is Frederick Gauss. Now he's an annoying kid. He always bothered the teacher, jumping on the table, doing stuff. It happened like 300 years ago, 400 years ago. I don't know exactly how many years ago. So the teacher eventually got mad. So the teacher told him to sit down, and he doesn't want to sit down. So he's like maybe ADHD or something. I don't know, what is it. So then he's like, well, you give me something to do, I will be quiet for like next 10 minutes. So the teacher says, okay, fine. Add 1 plus 2 plus 3 plus 4 all the way to 100, right? The story of this is he figured out this in a couple minutes. He's 8 years old, put in mind, he's 8 years old. And he figured out, he come back, he told the teacher. He said, my answer is this. And the teacher turned around and says, hey, I don't think you have the right answer. So the teacher go in and calculate it, add up each number, like 1 by 1, right? All the way to 100. And he double check the work, and takes about 20 minutes. He got an answer of this answer, and it was exactly matched to this answer, who was produced by an 8-year-old kid. How did he do it though? Do you guys know the story? You know, good. Because you're Russian. Why do you know? Miss can tell you. Okay. But everybody else doesn't know. Do you know? Can you figure out? How did he do it? 8 years old can figure out this. At 8 years old, he can figure out. Think about it. You guys can figure out if he can do it. He can do it. Yes, Jocelyn? What'd you say? Can you say that?
I think when you did this where it was like 6, 17, where it was pretty much divided by
I don't think you're on the right track. Yes.
Isn't there like 50 pairs of 101? You just.
Yeah, how do you know about this?
Huh?
You learn it from somewhere?
No, it's just.
You figure out, right?
Yeah.
Do you know what she said? She said there's a 50 pair of 101. How did she get 101? Yes, Bao?
Like 100 plus 1 is 101, 99 plus 2 is 101, 98.
Does that make sense? You think about it, right? Mathematically speaking, we can figure out a shorter way to look at it. And in media, nobody ever told her, but she figured out. So, but she's pretty impressive, but she would be more impressive if she can tell me that when she was 8 years old. Now, Frederick Gauss was able to do that in 8 years old. Not only you know Frederick Gauss is also has a big contribution in physics as well. He's not only a mathematician, he's actually a physics person. There's actually a law named after him besides the theorem. It's called Gauss's law. But when you go to physics, you're going to learn about Frederick Gauss. It has Gauss's law. Is the diameter of the wire can conduct how much electricity. I think that's what it is. I don't remember because I'm actually not good at physics. But if you take the first number and the last number, you add it. It's going to be 101. If you take the second number plus the second to the last number is also 101. 3 plus 98 is also 101. And you're going to do that continuously until you get 50 plus 51 equal to 101. So basically, it's 101 times 50. That's equal to 50, 50. And that's the answer. So math is to learn how to think. Most of your math teacher in the before, they just give you similar tests and you just memorize how to do something. But for me, I'm going to challenge you how to think rather than how to memorize, because you're not going to survive next year if you just know how to memorize something. I told you, one class in the classroom, only one person have A. Pretty much every single class out of my 4 classroom. I don't give A easily, but doesn't mean I will not give you A. They have to earn their A. I have a path for them to earn an A. A lot of people actually end up doing pretty well. I give out most A in the school. But with that being said, you have to work to get there. You also need to learn how to think like that. Think is more important. How to memorize how to do a problem is not that important. Nobody will memorize like 20 years later how to do something. But if you learn how to think, you can always apply it. Okay, so this is the part you have to think. So that leading term is going to affect something. Leading term is going to affect something called M behavior. Have you guys ever heard about M behavior before? In Algebra 2? No? Yes? So what is M behavior? Can you tell me anything about M behavior? Yes. Okay, good. Sydney? Did you raise your hand? No. No? I thought you did.
No.
I swear you did.
No, I didn't.
Okay, M behavior is what happened at the end. And how they behave. Are they going to go up or are they going to go down? Okay. So I'm going to give you a categorized things. So I'm going to say there is 2 things can happen affect the M behavior. It's only on the leading term. So so I'm gonna say it's, n is equal to odd and n is equal to even. Okay, which n I'm talking about? This n right here. That tells you how many solutions. The n. Now a is equal to positive and a is equal to negative. It tells you everything. Now I need you to pay attention here because this part is kind of confusing. And a lot of people, it's easy point. You just have to understand what is going on. So this one means this is a positive. I don't know how to write positive nicely. So this is positive, and this one is negative. Is that okay? So let's start with n is odd. Very easy. N is odd, a is positive. You can memorize this two arrow like this. However, I will never put that on the test. On the left side is down, on the right side is up. Or how do I know that, right? Just think about the easiest function you can think of. You don't need to memorize this. What's the easiest function you can think of that has odd as exponent and positive in the coefficients? 2x cubed, good. How about you, Amelia? Linear. Linear is even faster. But just say y equal to 1x to the 1, right? What happened here? If I just graph it, this side is going to go down, this side is going to go up. Does that make sense? Now, except you cannot say it's down, up. But this is the easiest way to memorize because y equal to x. Everybody knows that. If they are odd function and they are 1 in the front, it's positive. So here's the part that's going to confuse you. This is the first time I'm going to introduce you an idea called limits. And I always start looking for the left first. It's going to be limits as x approach negative infinity. What the heck does that mean? X approach negative infinity. That means I'm looking to the left. Is that okay? X approach negative infinity. Left. Of the function. What happened to the function? If I go into the left, what happened to the function? Going down, right? So that's going to be negative infinity. Is that okay? Because that means it's going to go down. So this is how you're going to write it. Limit x approach negative infinity. Limit x approach negative infinity is on the bottom. F of x is there. It's equal to negative infinity. Is this confusing? I'm going to do that again. So this is to the left. Now, how do I do it to the right? Limits as x approach what? Positive infinity. Good. Is equal to what? In this case. And that's it. That was the test question. Is if I ask on AP exam, they'll ask you the M behavior. Is that okay? Now I'm going to try again. So which one is even? What's the easiest even function that you can think of? And a is positive. X squared, good. It does have even. It does have a positive there. Does that graph look like something that I know? Is that okay? Can you tell me the end behavior on this using the term of limits? I should let you try it this time. If it's okay to get it wrong, go ahead and try it. I'm gonna start on the left first. How do I say left? X approach what? And f of x, that means the function is equal to what? Not negative infinity. Positive infinity. Because it's going up. Look, on the left side, it's going to go up. Does that make sense? Going to positive infinity. How about limit x approach to positive infinity of f of x is equal to what? Positive infinity. This is up, up. But if you told me up, up, I won't give you a point on the test. But if you told me this, I give you a point. Is this hard? No, let's try again. How about a is negative? So think about a is negative, but it's odd. So I can just think about negative x to the 1, right? That's negative. A is negative, right? What does y equal to negative x look like? It goes down, but it's going to go this way, right? Is that okay? It's a negative slope, right? So can you write an end behavior this time? You write it. Limits. X approach what? Negative infinity, always going left first, is equal to what? Does it make sense for everybody? Gabby, does that make sense? Samuel, does that make sense? How about Samuel? It's approach, limit x approach, what the second one's going to be? Well, the bottom first. Limit as x approach what? Positive infinity of f of x is equal to what? Good. So can you tell me what's the next one going to be? I'm not going to give you a graph, but I'm going to tell you a is negative, n is even. Think about a graph that is like that. Okay. You guys finish writing? What do you think negative and even look like? Which arrow will I draw? Huh? Two downs, good. So a good is negative x squared, right? And so it'd be limits as x approach negative infinity of f of x is equal to negative infinity. Limit x approach to positive infinity is equal to negative infinity. So that is the proper way to write it on all of them. Now I'm going to show you what happened here. Let's just assume that there is some functions, right? And I don't know what it is. F of x, and then we're going to say is equal to 5x to the 7, 5x to the 7 plus 6x squared, x to the third. This is a polynomial, by the way, minus x plus 4. Something like that. But if you pay attention, it's up for 7. 7 represent how many zero they are, how many roots they are. Is that okay? 7's gonna, according fundamental theorem of algebra, it's gonna give you 7 zeros. Doesn't mean 7x intercept. Something that you cannot see is invisible. It's not real zeros. But in this case, that it's gonna give you. In this case, we only see one x intercept, but there are maybe 6 more complex zeros. 6 complex zeros, and that's, I cannot use decimal to graph it. You cannot see it. But total, there was 7 solutions. Now, if you look at on the left, this is the same thing. Y equal to x. It's like odd. So, right? On the left side, it's going to go down. On the right side, it's going to go up. Do you see that? Now, if I change this to negative, just like negative x, look at that. I know what happened at the end. I don't know what happened in the middle, but I know what happened at the end. What happened at the end? This side's going to go up. This side's going to go down. Is that okay? That's it. I don't need to care about anything happen. Let's change this to 6. Down, down. Because even and negative is just like negative x squared. So it's going down, both sides. If I change it to positive, up, up. They follow the same pattern. So that's why I call it, they call it M behavior, or it's called leading coefficient test. Also known as the M behavior test. Okay, it depends on which things that you tell. Is that okay? They are not hard. They are very easy. They are something that you know already. And you know what? I can change this to 100th power. It doesn't matter. It follows exact same pattern as x squared. Got it? Right? So, by the way, most of you guys probably never seen this, but I'll show you. 5x to the 100 power doesn't look like this. Look like a parabola, but it's very, 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 very extremely flat. The more zero I put here, right, it becomes like almost a straight line. I think it's gonna be like this, a U, perfect U shape. They're more like edging. They become like 90 degrees. It was supposed to be round, and the more degrees it got higher, it's going like this. And if I put a negative sign in front of it, it's face down. Not rocket science. 218. Okay, that's it today. I still didn't finish give out the other test, but I think I take it home, so I'm gonna give it back tomorrow. You can take it at home. You should look at extra credit question though. A lot of people didn't know how to do the third question. All those extra credit question are good.
You're gonna pass up candy.
I don't have candy. I'm too cheap. Like,
The kids go around the neighborhood.
oh yeah, that my wife's gonna prepare that. You don't know where I live, do you? I have a gun.
Oh.
No, I'm just kidding. I live right across from Brendan.
Remember now?
Brendan Liu. Like he on a hurricane day, like bunch of them. Joshua, him, Cadian, they decided to come in, stop by my house, knock on my door. Huh?
I don't know what that is. I'll ask them for you. Figure it out.
What can I do to not make those mistakes? Like, you
What?
see, today I solved all of it like in less than 1 minute. I didn't divide by 2. Like that's all I did.
Yeah, that's
It's like because I'm trying to be too fast, or like
yeah. That's why I say you're too confident. You're too confident about your ability. Like I would tell you like the best. Like I say, I used to do fencing. Um, the best fencer in the world, they are not up or not down. They're very mutual. When they fence you, yes, they know they're better than you, but they're not gonna act like it. There are good fencer that act like it, but the best one, they don't act like they're better than you because they stay very very level headed. They still gonna analyze you. They still not gonna they're not gonna they're not gonna be like underestimate you. So the problem is you underestimate a lot of things. So because you're a very confident person, that does not means bad. This actually means good.
I was missing.
But you have the control of the study
I
stuff
don't even
that
know
you
like
do.
what to do though. Like,
Huh?
I don't even think I think like that, but like you're saying that, I actually realizing it. Like,
No. I mean, it's just like you overestimate problems or you underestimate a problem a lot of time. But the thing is, like sometimes you're gonna have to look at more detail, and you cannot stay you this thing's easy. The things that you always say is like this problem is easy, but every problem there's something to learn from. Everything there's always to learn from. Like teaching, if I go into a teacher I don't even like, they are way worse than me. But I go into a room, I will find something I can learn from them. It doesn't matter how good or how bad they are. They might do something that's really good I did not do, so I'm gonna steal it. I'm gonna make it myself better. Those are things that I'm tended to do when I'm teaching, right? So those are things that but you do it fine. You cannot let those confidence break you. You just
I'm here. Can I come in? No? Okay.
today's
You think Mr. would get back? Yes, he would. This year. This year. What? Yeah, could I have it? That's where you just submit. He never said that he liked it. I don't understand why you don't think he does. Like, what over? No, I mean, I know he does. He never says.
Why are you always charging my phone here? I gotta charge phone to somebody else. Now I cannot charge her iPad.
Can I wait for it to turn on at least? Alright.
Okay. Why you don't turn on?
I was completed. I just need to call home and like so they know where I am. I can go.
Yeah, he needed USB. He needed like iPhone charger.
Not the new one. I'm not very Fuji. I'm not putting on the jar.
Fuji.
Is it on? Okay, it's turning on.
I was finishing the question that we did in class. So I was trying to do this,
Good.
but I'm confused because I got one of my x's to be this, but it's not on here. Only 3.
Square root of 0.5 is 0. Try to type in square root of 0.5.
Yeah, my dad.
No, just type in square root. Just type in square root.
Right now. I'll do it when I get home so I can get the high quality version.
Because when I was,
And there's a negative one too, because
I clicked on all of the x's.
yeah, but there's a negative one. Look, you forgot there's a negative 0.7 as well. Because you square both sides.
Mhm.
If you move the one over to the other side, so it'll be x squared equal to 1/2. So if you square both sides, x equal to square root of 1/2. Plus minus.
Plus minus.
You forgot the minus part.
Okay, but here there's only 0, negative 1 point something, and 1 point.
Yeah, but this is inflection point. Inflection point is different. This is based on the new coordinate I give it to you.
So this doesn't have to match.
This does have to match this, but this is the second derivative. Second derivative equal to 0 happen at 0 and square root of 2 over 2. Plus minus. So you should get plus minus on both sides, and you have to do a number line test on both. But this is
Manny, can you
going
come
to
pick me up?
cavity and stuff like that. This is going to only tell you inflection point, however.
Coming. Bye.
After this point, if you zoom in enough, after this point, it's going to change in the concavity.
This is different Jordan. Where's the different?
Charging her. You got enough?
Yeah, because I think I messed with people. This is right. But then once this middle part is confused on.
I don't think this is right either. There's something after 1 as well. After 1. We only do this to -1. This is actually negative. Because you had to plug in negative and this is zero. If you plug in 2, it's going to be negative. If you plug in 2 here, it's negative. And then there's another point here when you have to do it.
Okay, thank you.
I'm charging, but it's not charging right away. That's fine. It's not very long though. Yeah, just yeah, this side. There we go. Is that enough? Yeah, there we go. There we go.
She was like freshman year.
Not mine. Not mine. Hey, can you just burn the test? Give me a 0.
I probably will.
No, wait. Don't do that. Don't do that. I'd rather have a 50 wrong.
That's pretty bad.
Okay, if I vote Democrat, will you give me extra credit?
And now I'm not gonna do something against you. I'm gonna ask you don't vote. But again, it doesn't really matter about your vote. Florida is only matter Pennsylvania. The swing states. Huh?
Well, I guess not after the
Not anymore. We have 1 million more registered Republican than Democrat voter.
Awesome.
Florida is it's being red for the last 10 years.
Are we gonna have BC homework today?
Yeah. Why?
Oh, so tired today.
Tired today?
What?
Tired today?
Yeah, for the past week, I've got every night I need like 5 hours of sleep, and I've been busy all day. So test and grade.
Yeah.
Did you do the mechanics thing?
Yeah. Yeah, kind of. I think it's like, yeah.
Mr. Greenwald doesn't.
Yeah, last year Greenwald actually taught me a little bit.
Is this like everything the guy gives? Like, is it based on, like, reading around?
Videos. And then we'll just give us homework. I don't know where the homework comes from. Probably comes from
The shift. That's your last test. Not really. I mean, but this was not good.
It's lower than Gordon.
It's slacking.
Yeah, I know. Who are you talking about? Really? For C? I did the entire remix song, right?
Can you make sure you understand?
You can understand.
Maybe make sure you understand.
Okay, listen. Yeah, it's integrals. You should know this. I did everything except the computer. Do you want to do that PC question right now? Does the stuff on the board matter, or can we erase it? You can erase it. Alright, cool.
Corbin, go learn how to do something. Not allowed to change anything. I go learn how to fix it.
Alright. Make you wear like tight clothes and then start hugging each other.
Who?
That's the link us say. Oh hell.
Well, you're not insane.
I'm gonna go.
Finishing up what let me try to take you on this first one because I'm not getting it. It's okay. And you're in the computer.
Yeah!
Change boundary. Yeah, because of use substitution.
Ah.
I know 2x.
I told him to do that. On this question on the test, I'm not doing the thing where you slow it over.
Then you do F of and basically do the planning.